AC generator. Do you know that most of our electrical energy comes due to the spinning of rotors in the AC generator of power stations like nuclear power stations, thermal power stations, and hydroelectric power stations, and so on? What is an AC generator? An AC generator is a device which converts mechanical energy into electrical energy. AC generator was originally designed by Nikola Tesla. What is within? Listed here are the contents of this module. The working of an AC generator is based on electromagnetic induction. That is, whenever the flux passing through a circuit changes, an EMF is induced in it and a current begins to flow. The direction of induced EMF is given by Fleming's right-hand rule or Lenz's law. Fleming's right-hand rule. Stretch the forefinger, the middle finger and the thumb of the right hand, such that they are mutually perpendicular to each other. If forefinger indicates the direction of the magnetic field, thumb indicates the direction of motion of the conductor, then the middle finger indicates the direction of the induced current in the conductor. Lenz's law. It states that the direction of induced current is such as to oppose the very cause producing it. Components of an AC generator. An AC generator consists of a magnet with concave cylindrical poles, an armature, and a current collecting arrangement. The current collecting arrangement consists of slip rings and brushes. Armature is a soft iron core on which a coil having a large number of turns of insulated copper wire is wound. Magnetic poles are concave and cylindrical. The concave poles produce a radial magnetic field. Slip rings. The ends of the armature are connected to two slip rings. They rotate along with the coil. The slip rings are made of metal and are insulated from each other. Brushes. There are two brushes, B1 and B2, made of carbon. One end of each brush is in contact with the rotating slip rings and the other end is connected to an external circuit. Here the brushes are connected to a galvanometer. Observe that the brushes do not rotate with the coil. Working. As the armature rotates about an axis perpendicular to the magnetic field, it keeps on changing its relative orientation with respect to the field. Thus, the flux keeps on changing continuously with time. This change in magnetic flux induces an EMF. If the outer terminals of the armature are connected to an external circuit, an electric current flows through it. The deflection of the galvanometer needle indicates that an EMF is induced. Graphical representation. Observe the plot and the movement of the coil to understand the sinusoidal nature of the induced EMF. Time to explore. Explore and learn the workings of an AC generator. Play around with the frequency and the direction. Observe the deflection of the galvanometer needle and the change in the nature of the graph. This will help you understand the workings of an AC generator.
Alternators are the workhorse of the power generation industry. It is capable to generate AC power at a specified frequency. It is also called a synchronous generator. Electricity is produced in alternators by electromagnetic induction. To generate electricity in a coil, either the coil should rotate with respect to magnetic field, or a magnetic field should rotate with respect to the coil. In the case of alternator, the latter approach is used. Rotor and armature coils are the two main parts of an alternator. Rotor produces a rotating magnetic flux. Armature coils are stationary, and rotating magnetic flux associated with the rotor induces electricity in the armature coils. This kind of rotor shown here is known as salient pole rotor. For gaining better insight of its working, let's consider a rotor with just 4 poles. Rotor coils are excited with a DC power source. Magnetic field produced around it would be as shown. The rotor is made to rotate by a prime mover. This makes the rotor flux also rotate along with it at the same speed. Such revolving magnetic flux now intersects armature coils, which is fitted around the rotor. This will generate an alternating EMF across the winding. Here is a slowed-down version of rotor-stator interaction. For this 4-pole system, when the rotor turns half revolution, induced EMF takes 1 complete cycle. It can be easily established that frequency of induced EMF, rotor speed, and number of poles are connected through following relationship. It is clear that frequency of electricity produced is synchronized with mechanical rotational speed. For producing 3-phase AC current, 2 more such armature coils, which are in 120-degree phase difference with the first, is put into the stator winding. Generally, one end of these 3 coils are star-connected, and 3-phase electricity is drawn from the other ends. It is clear from this equation that in order to produce 60 Hz electricity, a 4-pole rotor should run at following RPM. Such huge RPM will induce a tremendous centrifugal force on poles of the rotor, and it may fail mechanically over time. So salient pole rotors are generally having 10 to 20 poles, which demands lower RPM. Or salient pole rotors are used when the prime mover rotates at relatively lower RPM. Pole core is used to effectively transfer magnetic flux, and they are made with fairly thick steel lamina. Such insulated lamina reduces energy loss due to eddy current formation. Armature winding of three-phase 12-pole system is shown here. A stator core is used to enhance magnetic flux transfer. DC current is supplied to rotor via a pair of slip rings. DC current is supplied either from an external source or from a small DC generator which is fitted on the same prime mover. Such alternators are called self-excited. With variation of load, generator terminal output voltage will vary. It is desired to keep the terminal voltage in a specified limit. An automatic voltage regulator helps in achieving this. Voltage regulation can be easily achieved by controlling the field current. If terminal voltage is below the desired limit, AVR increases the field current, thus the field strength. This will result in increase in terminal voltage. If terminal voltage is high, the reverse is done. Hope you had a nice introduction to working of alternators. Thank you.
The generator looks a little large sitting on this trailer, but on the ground it's only about 3 feet tall. Most people can power everything in their home. So if the power fails, you can keep using your home appliances as you normally would. The lights can stay on, the air and heating can continue to work, water pumps don't need to turn off, and your fridge and freezer will keep your food fresh. You don't have to change the way you use electricity. While others are looking for power cords and trying to start their portable generators, yours will already be running. That's because everything is fully automatic, so you don't have to leave the comfort of your own home. Now watch me start this generator and listen to the small plane flying overhead and the noise of me walking. It's louder than this generator is.
Camera set up about 23 feet away. I'm talking at a normal voice. I'm about to start the generator, turning the key, and it's probably no louder than my voice is right now, 23 feet away. I'm still talking at a normal voice. Nothing has changed. The generator's running. Close the door. It's still louder than I am. Walk 23 feet away. Talking at a normal voice. We're looking at maybe 50 decibels, no louder.
Now notice the exhaust from this generator. It's perfectly clear. There's no visible smoke. There's also no bad smell either. Now let's have a closer look. Notice the weather stripping around all doors? It protects your generator from water damage and also helps reduce noise levels. This generator also comes with an automatic transfer switch. When the power fails and your generator starts up automatically, it will safely disconnect your home from your main power source and direct it to this generator. And when the power is restored, it safely switches everything back. As an added safety measure, the generator itself is also protected by a circuit breaker. The final electrical hookup to the generator can be through these holes here or through the bottom of the generator. Normally everything is set to run automatically. If you ever want to start the generator manually, it's as simple as turning a key. If you ever need to access anything for service, you'll find everything is very well laid out, easy to identify, and properly labeled. Fuses are easy to check and remove. and relays are installed on sockets, making them easy to remove, and when your generator is not running, this power supply keeps your battery charged. The back of the panel is also very neat and organized. The generator uses a simple controller like this one, or in many cases with our newer generators, an upgraded one that has a small digital display on it that provides additional information on it. The purpose of the controller is to monitor your generator and take care of automatic starting, even with the generator locked up and secure. A quick look through the panel window will tell you everything. Now, if you're wondering about the generator head itself, it's maintenance-free, brushless, and uses an automatic voltage regulator. There are a variety of engines available, but no matter which one you choose, they're all designed to last over 10,000 hours. They also all use a large heavy-duty muffler. Now, your generator can come in different colors, but no matter which one you choose, they are strong finishes and rust resistant. So are the hinges and all the other fasteners used on the generator. Now, if you'd like to learn more about these generators, please contact us or visit one of our websites. Be sure to check out some of our other videos as well.
아니 안 불러도 돼요. 이거 들라고 그러는데요. 네. 이거 떨어져. 저기 밖에 이제 끼워야 되겠다. 이게 엔진인데. 일단 그래도 괜찮아요? 뭐 잡아먹는 어디 갔나? 이게 좀 더 가까이 가야 되네. 지금 여기서 이만큼 스푼 나가는 데까지 밀어보면 이런 좀 당기고 있잖아. 찍었어요.
원래 이 코에 자석이 안 붙는 거 아니야? 어? 코에 자석이 원래
아니죠. 아생 그거 다 자기가 돼가.
The cardboard is to protect from the shavings coming up to the finger.
조금만 있어주실래요? 그대로. 그냥 팔에 내놔주세요. 그대로. 됐습니다. 해 천천히 밀어. 반대 내태우시고요. 조금씩 들어가시면 뭐 종이 달려들어간 거 있어요?
아니야, 그게 아니라 진짜 많이 나는데.
일단 가까이 한번 가봐요. 가까이 가도 돼요. 괜찮아요.
그죠? 사장님, 차이가 많이 나잖아?
들어가? 네, 괜찮아요. 넣어보시면 괜찮아요. 괜찮아요. 그쪽 갈게요.
박스를 조금 더 대주지, 저거.
예, 그래요.
벌려. 중간이 센터가 안 맞으니까 그렇게 벌리는 거야.
그러면 여기서 그 살짝 위로 그냥 여기 가는 거 있어요. 여기 들어가면 됩니다. 여기 잘 나왔어요. 박스가 걸렸구나. 박스가 걸렸어요. 이분도 올때 빼버려. 안 보이니까.
빨리 들어가니까 그러지 말라고 하는 거지.
이렇게 나왔거든요. 살짝 부를게요. 이게 나왔어요. 제가 이렇게 나왔으니까.
이거 안 들어가서 다 들어가서
다 들어간 거 아니에요?
여기 까만 선까지 들어가거든요. 샤프트가. 긴 나사를 쓰다가 일단 꽂아볼까?
지금은 그렇게 할 수도 없고. 그거 안 써가지고.
사장님들이 깎아서 다시 해줍니다. 이렇게 이렇잖아요. 왜 이게 안 맞아? 딱 맞아야 되는데 원래 딱 맞아야 되는데 사람들이 며칠을 이런 거